So, hello everybody. I'm giving a talk about microservice UIs. I'm going to explain that in a few seconds, what I mean by that. So my name is Heribert Schütz, and this is just for the record. Focus, I was wrong. So in a project where I'm currently working, well, what is the situation? The project is for multiple companies that are part of a group, and these companies have common customers, have separate customers, and up to now they have separate UIs for their customers, and they want common UI for several purposes, so it's more convenient for the customer to use, and of course the business case is that they also want to do some cross-selling, so sell product from company A to the existing customers of company B and vice versa. But still, these are separate companies. They have their own data sets, they have their own functionality, and they are responsible for their own business. So it's necessary not to write a monolithic application. And we've actually already seen it in the previous talk, where Daniel painted this picture with the layers. So for the ones who are here just behind the column, maybe you go a bit left or so. So you start with some database, and then you have, say, in your server, a data access layer, and some business logic layer, and some whatever REST adapter, and then in your client you have your communication layer, and your state, and your actual UI, and whatever. And if you structure things like this, it's hard to get it running if something broke, say, at this place, or if you say want to change something right here, because then you have to touch all the layers. So it's typically better to use some sort of vertical slicing of your functionality, where you have a module that covers all the layers of the tech stack for a particular functionality. And I think the picture already says everything what I wrote on the slide. So actually, if you do that just on the server side, then you've got a microservice architecture. You have relatively fine-grained services for business functionalities. And what does it give to you? The services are loosely coupled. So the services must have well-defined APIs to communicate, maybe not only to the front end, but also to each other. But and this API is relatively rigid. It's not so easy to change, and so it's not so easy to break things. But what it gives you, you're independent with respect to the tech stack. So you might want to implement one of these services, say in Java plus React, and another one in C# plus TypeScript plus Angular or whatever. You can develop these columns relatively easily, relatively independently. You can also build test, deploy these columns in a relatively separate way. Of course, in the end, you still need some sort of integration tests, but that's then at the top of the test pyramid, and therefore not that much to do. Relatively realistic case for us is you want to upgrade some third-party library that you're using in your code. Well, if you have this horizontal partitioning in a monolithic system, then you have to upgrade that third-party library typically for all of the business functionalities, and that often lets you think about the risk, and you say, okay, maybe it's too risky, and you don't do it. Now, if you can restrict such an upgrade or a technology change to a particular microservice, then you just do it where it really benefits you, where you really get a benefit, and you leave the other microservices as they are. One final thing, you can even shut down or restart a microservice without breaking the entire system, well, if you do it right. On the microservice side, scalability, in particular, if your services are stateless, is a main argument for using microservices. And I don't know, but the last line is so low. Well, in the hype cycle, microservices are maybe still in the boom phase. So I can imagine that currently microservices are being used in cases where they are not appropriate, but I think there are valid use cases where to use them. So that was on the server side. Now on the client side, we would actually also like to benefit from the same advantages. Well, maybe not the scalability issue, because all users have their own clients, but yeah, you want to decouple things. So if you use a traditional multi-page application, or if you use IFrames, you actually have quite a good decoupling. You have different namespaces for your JavaScript, for your DOM, for your base, or for whatever. And these different frames or pages might need to communicate, but that's not just by simple function calls, but really via, say, messages, or via service workers, or a client-side storage perhaps, or even via the server. So it's always a bit more difficult to communicate if it's needed than just a function call. And that gives you some incentive to really limit the communication and make the UI parts independent of each other. But, well, in at least our use case, we're not able to simply use that approach. The reason is that this has been decided to be not good enough for the user experience, in particular on mobile browsers where you don't want frames, or they are maybe not yet fully supported. So actually, I must admit, I don't really understand the implications of these problems, but that was, say, a decision that has been made before I joined the project. So I tried to find a solution without multi-page and without iframes. So single-page applications are, I think, state of the art, and they tend to become monolithic. So typically, if you Google for microservices and look at the pictures, then you see something where the services are cut in pieces, and then the client, well, is one big mess. No, is one big block. So with monolithic code, well, you get all these problems that I mentioned before. So if every module might call every other module, then, well, in development, you don't know if I change something here, what could it all break? Of course, you have all your tests, and tests will hopefully tell you, but, well, not everyone. This has complete test coverage on the integration test level. You, well, typically are better off with a uniform tech stack. The build chain or build, test, deploy typically works then on the entire application. So if you want to test something, you might have to wait, say, in the edit, compile, test cycle for a longer time than in other cases. So Webpack helps you in this place, but not in all cases. As I said before, here you have the synchronized upgrades of third-party utilities, and if you want to remove or shut down a component, you need a complete redeployment. So what can we do about that? So the idea is essentially, well, we need some sort of root application up here, which binds all the pieces together. The root application somehow fetches in a situation-dependent way a list of services which can be chosen by the user. So the services are simply identified by URLs. The user selects one of these services. The URL is loaded. The resource is actually a JavaScript code. And what the root application does, it invokes that JavaScript code. Actually, it's a JavaScript function in our implementation. So we have here server part and the client part. So we first fetch the UI, the static resource essentially, containing the JavaScript, and defines the function, as I say, and it gets several parameters. Actually, a DOM element, where it's being told, well, you can render yourself in there, possibly backend URLs, so that the service UI can talk or can find its backend. It might also be the case that we just send the service URL itself, so that it can find its backends, its API, via relative hardwired links, some authentication credentials, whatever, certain utility callbacks like a notification, I'm done, you can close me, logging, web tracking, error reporting, some, say, very generic stuff, not too much what we have in the API. And the service UI just render some DOM into that given DOM element, and React is particularly good at that, so you just use React DOM's render method here, and then it calls it communicates with its microservices and uses the callbacks that we sent, that I mentioned on the previous slide, as needed. So how do we compose code? Well, our first attempt was, since we were using Webpack anyway, to see whether Webpack supports dynamic loading, and actually it does. But but at least the version of Webpack that we looked at was only, well, it was able to do a sort of monolithic build everything at one time, and then you could still decide, okay, not all of the modules that were tagged together should be loaded immediately, but certain modules should only be loaded on demand. But still, say at build time, you need everything. And as I said before, with different companies playing a role in this project, and yeah, we cannot force one company to make a new release just so that the other company can change some of their front-end code. So we need something more dynamic, not just at runtime, but also at build time. And the next attempt, what we did, actually we means Tim and me, was a simple approach: fetch the resource, evaluate it, and well, then you've got a top-level function definition, and then you can invoke it. Problem there was eval ignores source map links, which would be very helpful, or which are very helpful for debugging if you use some pre-processing. We use Babel. And well, if you have to debug the code generated by Babel, that's not very comfortable. So it's generally better to load the code via a script element. And it turned out we don't have to invent that. ReactJS and also System.js provide such things already. Scroll a little. And but for some reasons, so that's just a minor note, for some reasons System.js didn't really, at least in our first tries, solve the source map problem. I don't know why that was. Maybe we just did something wrong. But in the end, we are now using ReactJS, and we're still using Webpack for assembling the microservice UIs. And we can tell Webpack with the library target variable that we can ask Webpack to build a resource or a bundle that follows itself the AMD conventions so that ReactJS understands them. So that's basically the approach. So still we don't have the strong decoupling that we would have with multiple frames or multiple pages, or that we have on the server side. We do have to follow some conventions to avoid clashes in shared namespaces. So one namespace is the namespace of IDs of DOM elements. We are living within a single document, and yeah, IDs are the same, or are, yeah, live in a single namespace. Fortunately, we don't need IDs very often in React. Well, if we were programming, say, with jQuery, that would be needed a lot more frequently. Then CSS classes. That's actually a real problem for us, because, of course, we want our entire application to have a uniform look and feel. So we want to use some shared CSS. Currently, we have to make sure that the CSS library used by the parent or by the root application is the same or is sufficiently compatible to what the service UIs need. Actually would be cleaner, and maybe we get around to do it, to use CSS modules or something like this, which simulates by pre-transformation of CSS namespaces for CSS essentially. Then JavaScript code is fortunately not much of a problem because JavaScript is statically scoped. Also Webpack packs all the top-level declarations of the individual modules files into functions, so they are hidden from the outside, and even what is exported is only visible to other functions which explicitly imported. So there we don't have that much, or we hardly have any problems. The only exception is where we need some global definitions, and the usual situation where we need global definitions is polyfills. The good thing about polyfills again is they are intended to follow a new or upcoming standard. So even if different service UIs load their own polyfills, they should be sufficiently compatible. So up to now, it seemed to work. Well, another thing is module names, package names, and versions. Typical situation, the service UI wants to upgrade to a new version of React or Redux or whatever, whereas other services or the framework UI still wants to stick with an older version. Using Webpack for packaging and hiding everything solves this because it's already resolved at build time, and so we actually benefit here from this JavaScript static scoping. The disadvantages, of course, if you have multiple different versions of libraries, it increases the code size. We have ideas how to solve this, but they are a bit hacky. For now, it's not yet really a problem. More things where we have to be careful is URLs. If we use relative URLs in a service UI, if you would simply use them in a fetch call, they would of course be resolved by the base URL of the entire application, of the root application, and that's typically not what we want. So what we have to do is we have to resolve it explicitly before using it. Resolve it by the URL of the service UI. And finally, there's the same origin policy. So when a service UI does backend request, it's living in the origin of the root application. So in the host name port pair for the root application, and even though the fetch call was loaded from some JavaScript call from the microservice, and what we have to do here is either to add course headers to allow the interaction, or to use a shared reverse proxy in front of all our microservices so that to the client it looks like being all the same. And in either of these two cases there must be trust between the different services. There we are sort of outruling the browser's security mechanisms, and that's only possible if all the providers of UI components are mutually trusting each other. So, as I mentioned before, it works well with React because React is all about filling some DOM element with some sub-DOM created by JavaScript code. If we have to follow these few caveats that I mentioned before, I also implemented a JavaScript, or sorry, a React component for the root application, helping it to load the child applications in a convenient way with some lifecycle methods, so that if this URL changes, the application is closed and the other one is loaded and displayed. Unfortunately, it's not published, so I didn't get all the release release approval in our project. So that's it. So if you have any alternative ideas to that, suggestions, questions, feel free to ask and to suggest.
How many different versions of React are you loading?
Actually, I don't even know. Well, within the one company that Tim and I are working for, we are trying to keep it compatible. Still, we load about different, even if it's the same version of React, we load multiple copies. And what the other companies do precisely, I don't even know. But in practice, it's not that much of a problem, because typically a user logs in, selects one of the services that is available for the user. Say, there's some subscription at one of the companies, wants to change something with the subscription there, and then that's it. And say a few days later, he needs another service. So typically, you have the root API, the root UI plus one or two, maybe three services that you're loading in a typical session. So it's not that much of a problem as if you would have hundreds of different services loaded.
And like the different applications inside your application, they seem to not share many like data, for example. So, or like what I'm thinking of is I got one component and it needs, like, let's say the username and the user profile picture, and another also needs the username and profile picture, and then both would go to the server and request it, right? So they cannot share any like client-side caching or stuff like this.
Yeah, well, that's true to some degree, but mostly for authentication, authorization purposes, we have really repeated work in the microservices, but from the actual, say, business data, it's quite well separated. So, there's, for example, one service asking, well, what subscription do I have? And then you get a list, and then, of course, you can select the subscription and then select services for that subscription, say, change the payment interval, whether you want to pay monthly or yearly, things like that. So, except for the sort of links that you have, say from the identifier of the particular subscription, there's not that much shared data.
And also that there is no way for like the applications to communicate with each other, right? So like
you mean on the server side or
on the client side? So what you have with IFrames and like this post message where like you're part of like your UI component A can talk to your UI component B, so they can like share whatever they want to share between each other. Or isn't that a use
use
case?
this params interface to communicate, so you can pass any object or any call.
Right, makes sense.
Yeah, like as I wrote on one of the other slides, authentication credentials or callbacks for web tracking or things like that. But actually, we on purpose limit the amount of or number of these parameters. It's actually only technical things, no business data.
Also, the user name or the name and surname is also not passed from the root application to the services.
Yeah,
because
actually
it's not wanted by the architects.
Yeah, exactly. In an earlier version, we had the idea that the root UI anyway knows the name of the logged in user. So if a service UI wants to talk to the user, dear Mr., dear Mrs., then it could get the name and the gender this way. But we even rejected this approach, and the microservice fetches it another time from its database. We have that round trip anyway. We need to know about its, say about a particular subscription, and when we ask for the information about the subscription, we just get in the same round trip another time the name of the customer so that we can use it.
Unfortunately, we don't have GraphQL there, because then it would be really easy to write name and things like that into the query.
Okay. I don't know who was first, so let's start at the very end and then go forward.
Go. Like you said, you're using, like what does the contract looks like between the modules or the root application and the like separate modules? Is it really just like a mount point that like passes a DOM element where the other apparatus into? Or?
Yeah, the contract is actually what I said before. The child API or service API is a JavaScript resource in AMD format.
Okay.
Defines one function, and that function takes these parameters, where actually some of them, namely the DOM element and this service UI, are provided by this mount point component, whereas the other parameters, in our case, are provided as params from the root API. So, the social contract, not the technical contract, was essentially that the root UI is implemented elsewhere. So we are not the implementers of the root UI, but we were asked to find a way how to integrate our service UIs into the root and to make it easy for the root UI programmers. I implemented this mount point class mount point component and provided it to them so that they can easily follow the contract. Does this answer your question?
Yeah, does have you played around with things like web components or like web workers, which are usually like more, I guess, similar to like modular UIs?
Web workers are not yet fully supported in our browser matrix.
Okay, so I guess
web components, I must admit, I'm not really an expert in, so I actually prefer React there.
yeah,
So
no, I thought like you said you had problems with like CSS scoping and so on.
yeah.
Like usually, like my
Yeah,
understanding
but even there, but native support for CSS scoping is not yet in all browsers, and simulated scoping actually typically works with CSS modules or something like that. That was the reason why I mentioned the CSS modules here. So, well, in our case, we still have a shared CSS, which is not ideal, but well, sort of a compromise. Yeah.
Okay. Okay, you say that one of the problems that you have is different version of React on each different page that you want to go that in that way. So you create a React component that mount a point, an endpoint, a different point. Can be useful if you want to use more versions of React in the same project, for example. I was using a middleware that I think, I don't know how much people know, it's like Nexus. Is a server that potentially is a copy of NPM, but on a local server. So it means you can publish some components and import into your project. So potentially you can separate each part of your big app, if understood is very big, can be very big, and just elect the packages and webpack make these packages for single components, and you just make an NPM import, but not directly to the global NPM, but your local NPM. And so you can pass, for example, the component, you can pass all the state. For example, you have one module that has to collapse everybody, and just pass the status of the Redux, for example, store to each one of the different apps. So you resolve the problem of authentication.
So what was the last
You can
thing?
resolve this way the problem of the authentication, because you need, for example, login just on one point, on one points. And then all the app that you have it, you create this small part of your global app as other app that get into the state from a model, from a module that is upper.
Yeah, actually, I think there are two aspects where and I don't really understand how these two aspects are related. The one thing is Nexus for providing code in NPM packages. Actually, in the company for which we work, we have a private Nexus, but it's not group-wide, but it's company-wide. So we cannot really standardize on, say, a particular React version or so. And actually we don't want to. We want to be able to upgrade certain important APIs to the latest and greatest React version or whatever, Redux or whatever thing. And less important services and service UIs can stay as they are. Or if we have a particular problem we want to upgrade, but we don't want to introduce problems elsewhere. So that's the one thing. And the other thing is so that's at build time. At runtime, we were actually also thinking about sharing a common Redux state between the root application and the child application. But that turned out to be far too much coupling. So it makes communication, of course, easier, but it also makes it a lot easier to break things. And that's why we didn't do it. Actually, each service UI has its own Redux store, and that was an approach that worked very well for us. Does this answer your question?
Yeah, it was very similar to what I was saying.
Okay. Then is that from the back to the front? So.
Yes, my question was more like a thought, is about sharing state between different childs under the root.
Yeah.
So you mount different approaches, and you have those utility function params thingies that accept something, right? So assuming I put in an observable or a stream or something like that into both services, which I manage somewhere in the root, and I connect my state, my Redux, I don't know where the data comes from actually, to not have the round trip to the backend for simple UI changes, because that would actually annoy the user. So if I have to wait. Does it make sense? Is it possible? Would it be possible?
I could imagine, or I can imagine use cases where a shared state for several parts of the UI makes sense. But in our case, we were able to cut the services and service UIs in a way so that they are essentially self-contained.
So you don't need any communication.
Well, of course, you could. One thing that I could imagine, so it doesn't yet occur in our case. You have in the root or in one child UI a list of subscriptions. Customer clicks one of these subscriptions, want to work on that. Then in the service for this subscription, customer says, I want to cancel this subscription. Then it might make sense with some sort of optimistic updates in a shared state to tell the list of subscriptions to remove that element. So that would be a use case where it might make sense, but it's not really that frequent that we need that. We've found quite a good cut between the services. So actually in an earlier version, our contract between root UI and the child UI was that the root UI loads a JavaScript module exporting a React component, and then the root UI just instantiates that component within its own React tree.
And it needs to be a
That means a lot more coupling. It means a lot, but very easy communication using a shared state and so on. But then you you cannot update one React version if you need something newer, and keep the old React version if you don't want to touch a particular service because you don't have the manpower. So we went away from that tighter coupling to something less coupling. And as I said before, you can even write the root UI or some service UIs with completely different technology. So there's no real need to do it in React, but it's quite comfortable with React. So I think there was at least one more question, or no?
I have also a question. Has anybody of you similar problems? So is this something common, or is it just exotic because of the setting with those companies?
Used IFrames and the post message is, but our parts must communicate, and the post message is really cumbersome, and I don't like this approach to separate the UI in different components, because my opinion is that the UI should be one software. Then you can test this software and you can guarantee that the software is usable. And if someone breaks something, then the whole UI is not usable, I think.
Yeah, that's something that we actually want to avoid. Yeah, but it really depends on the use case, yeah.
Yeah, your software is separated, but our software must communicate.
Yeah.
So if it's not really a microservice, then it does not work.
We have something it's a huge form, and there is a separation, and there is an iframe, and what a part of the form does is sending data to the backend using signed request, sending the signed request to the front end, and the front end uses the signed request, sending it to another service, and displays the data as an iframe.
Sorry, display?
That's what we tried to use. All the data that the view needs to put into the request itself, that there is no database connection to that server. Everything that is used for the view is put into the request using a signed request. And with that, we have lots of requests against that service that just renders with image and text, but in general, this is what we do.
Maybe I should mention one more aspect about our use case. So the typical thing, the typical situation is also that only one service UI is active at a time. So we've got sort of a box in the UI where you can load this service UI, and then you can load another service UI. Since they are simply not active at the same time, there's not much need for them to communicate, only perhaps with the root UI. And that's what we do to some degree by passing down credentials or an identification of the user, things like that, or telling a service UI about a particular subscription for which it has been invoked. But at least up to now, we were able to keep it to a minimum. Yeah, but okay, I'm apparently repeating myself already.
Okay. Any other questions? No? Okay.
So, thanks a lot for your interest.
Yeah, I think then